Hello everyone, this is just my general recap on yesterday's Falcon Heavy launch and a little look out into the future. Now yesterday the Falcon Heavy did launch successfully. It brought the Tesla Roadster into orbit successfully. The Tesla Roadster and the Starman have since been transferred onto an escape trajectory and a extended elliptical trajectory intersecting Mars orbit, which I will make an updated orbital prediction on since the target orbit has changed, as they wanted to test how far exactly it would go in order to see how much fuel was actually left in the upper stage after the coast phase, so they can optimize future planning in terms of fuel use. Now, the left and right core landed spectacularly. The overall launch was fascinating to watch. It was pretty spectacular, pretty exciting, pretty amazing. And for me personally, it was also pretty interesting because I had the chance to exercise making a few predictions based on simulations of my own, and while I didn't get everything exactly right since I don't have access to every single design detail, generally many things looked a bit like I expected. So between that and SpaceX analyzing what data they got, we all learned a little bit from this launch. The center core was confirmed to have smashed into the sea next to the drone ship. It was some 100 meters away. However, it did crash down at 300 miles per hour since its landing burn ignition failed. Now, the entry burn ignition succeeded, so it still had one engine running from the entry burn that continued running through the landing burn, but with the additional two engines failing to ignite, it didn't slow down fast enough and it ended up crashing into the sea, and it also didn't have enough control to actually aim for the drone ship, luckily. So there might also be camera footage available once they recover the drone ship, which is currently a bit hard to maneuver since it is damaged. And it doesn't have a radio link either, so they will have to recover the footage basically from the SD card from the camera itself. And the exact reason why this happened is of course a bit mysterious and a bit interesting, since this is an issue that could have happened on any Falcon 9 launch, and Falcon 9s have become quite reliable by now. And we've all had our expectations as to what might go wrong on a Falcon Heavy launch, because it is new, it's a new rocket type based on the Falcon 9, so anything that has been changed against the Falcon 9, anything that is additional, might cause a failure, but everything that we already know to work from the Falcon 9 was expected to work alright, and the ignition of two additional engines on the landing burn has previously worked on pretty much every Falcon 9 landing. Now, of course, we can't assume this with 100% certainty. It might still, of course, be that this is just a really unlikely Falcon 9 failure, even though the Falcon 9 is quite reliable. It can fail. New unpredicted things can go wrong, even on the 20th flight of something. And it might just happen that this new unpredicted Falcon 9 failure just coincidentally lined up with the Falcon Heavy test flight to give us a failure on the Falcon Heavy test flight that actually has nothing to do with the new additions and is really just a Falcon 9 failure. It's unlikely, but possible, but still for it being more interesting under the assumption that it was probably caused by the changes of going to a Falcon Heavy, try to go through the possible explanations as to how this might have been caused by the new additions of going to a Falcon Heavy. Now, we have gone through the launch timeline before. There are a few new things, and we know that the ignition failure was most likely caused not by a failure of the ignition system itself, but simply by it running out of ignition fuel. The special fuel, not the actual rocket fuel, but the special fuel, it's got a really complicated name that I'm not gonna learn by heart and pronounce here, that isn't actually used as a rocket fuel, but as a fuel for a pyrotechnic torch that then ignites the engine for every new burn, every new ignition. That fuel ran out, so they had enough for the first ignition of the entry burn engine, but not enough for the landing burn ignition. Now, there have been a few theories about how the interaction between the stages or the staging might have caused this, but that is rather unlikely since those interactions were relatively weak at the bottom of the rocket, and so the actual ignition fuel wouldn't be too affected by that, so my theory is still that the re-entry of the car may have caused this. It is still one of the hardest re-entries, and the rocket engines on a Falcon 9 re-entry do basically double as heat shields. They're already proved against hot, fast-streaming gas, their rocket engines, and they're pointed into the re-entry, and more or less without choice their nozzles end up in front of the rocket and serve as a makeshift heat shield. And while the engine itself is shut off, the nozzle does of course fill with hot gas, and the engine gets affected by that thermically, which might cause some issues with the ignition system and the ignition fuel, which may have in some way missettled in its own reservoir and thus not been available to burn. That is of course always an issue with rocket fuel or even airplane fuel or car fuel. It's just you notice it more where it is more drastic and more catastrophic, that it's not really just about the fuel that is there, it's about the fuel that is actually available. For example, most rockets can't actually empty their fuel tanks because by that point the fuel pressure would be too low, and thus the turbo pump would no longer be able to properly operate, and the rocket engine would just flame out. Depending on design it might be a bit more catastrophic, but basically it would flame out, no longer work before the fuel is all used up, and there's a lot of other unpredictable things that can happen to fuel if you put it under untested conditions. If you warm up a normal fuel tank, it can happen that some of the fuel through the heat vaporizes in the fuel tank and you now have fuel fumes in the tank, but not as much actual fuel, and that can reduce the fuel you have left. Either way, it seems to be a rather fixable issue, and I'm still quite impressed that the core re-entry itself actually worked. I did kind of expect a failure to happen there, if anywhere, and of course the staging was just spectacular. Even though it wasn't exactly that incredibly risky, it was just amazing to see the staging mechanism in action, moving and mechanically separating these three huge masses. We then got some footage of the Roadster and the Starman and all the Easter eggs on orbit, and later on the final orbital data of the escape burn. For the future there are actually already further Falcon Heavy missions planned, and since it went well, even though it's still a very early rocket prototype, there are already proper useful satellite payloads signed up for it, and that will actually be the next Falcon Heavy flight, apparently with no further test flight in between. So within 2018, and actually quite soon, there will be the Arabsat-6A communication satellite mission, as well as the SDP-2 mission, which will be a cluster of military research and experimental satellites by the US Air Force. Of course, on the internet, in all the space-related groups, a lot of jokes and memes started popping up, and in the spirit of the day, I actually started finding some of them quite funny, including all the little jokes like Elon may have left his wallet in the car, and maybe the remote car keys still work, and suddenly a car door snaps open in orbit. Of course, highly unrealistic ideas, but it's funny, so what? SpaceX and Elon Musk have been somewhat encouraging on those jokes, which is maybe kind of why there is such a PR success. And between all the Easter eggs riding on the Roadster, the Hitchhiker's Guide Through the Galaxy, the Starman, the Tesla, David Bowie, the videos and tweets they posted, there are plenty material for jokes and nerdy insider humor. Then of course, aside from many well-founded articles, a few badly written and uneducated articles also popped up, like complaining about space debris, which of course in this case is pretty pointless, since unlike other test flights of rockets, this one actually didn't end up in an Earth orbit, which we still need and is already cluttered with space debris, but rather ended up on a transfer orbit which is over-elliptic and won't be used again and doesn't match up with any future transfer windows anyways, and is far stretched out and way empty, so it's really not a threat to anything at all. And while of course for fairness sake I have to point out that many articles and many news websites actually did report very well on this, it's always surprising that quite a few supposedly professional news outlets and media writers specialized on technology and future space exploration and such have little to no idea of basic orbital mechanics, or that every rocket has to go through some form of test flight, or just the general idea of scale. I mean, it is easy to overlook when you just see the live stream and it all looks so reasonable size because the camera is decently far away. It's just a image of the rocket. You don't have very much great reference, so it's quite easy to just think, oh, that I see an image of an object, it's probably a reasonably sized object since that's what I'm used to and I have no further information. So our brain just kind of thinks it's normally sized, but this thing is huge. And compared to it, a Tesla Roadster, for example, is absolutely tiny. Then there's things like how does re-entry work, why do things get hot when they re-enter the atmosphere? It's not because they're re-entering the atmosphere, it's just because they're really fast, which usually happens when things re-enter the atmosphere. It's not just some magic boundary that you cross and suddenly everything goes hot. And many other basic pieces of knowledge that tend to be missing from some news outlets, but luckily there is quite a big and active and well-educated space community by now, so these things do tend to get corrected, at least in some form of comment or such. Now with the Falcon Heavy launch somewhat behind us, I can kind of return to a somewhat normal schedule with my channel. I am now of course busy with a few other things that I have kind of pushed back because of the Falcon Heavy launch, but I do now have a bit more time to make videos not related to the Falcon Heavy. So again, I'm fully open to any questions about spaceflight. I will of course keep updating you and trying to analyze what went wrong with the center core and what else we learned from the test flight, especially as further analysis gets released by SpaceX. But apart from making a short orbital simulation of the final target orbit of the Tesla, this kind of concludes for now the coverage of the entire Falcon Heavy launch event. And of course, as always, thanks for watching.